9.1-2 final example problem number 2. The Earth has a moment of inertia of 8.04 times 10 to the 37th kilograms times meters squared. Its angular velocity is 7.29 times 10 to the minus 5th radians per second. If a torque acts on the Earth for 0.15 seconds and it decreases the angular velocity to 7.27 times 10 to the minus 5th radians per second, find the magnitude of the torque. Okay, this problem, once again, documenting everything that we know for sure. Our moment of inertia is 8.04 times 10 to the 37th kilograms times meters squared. Now, moment of inertia can change, but we're talking about the Earth here. It's not going to change. The mass of the Earth is pretty well set. Even if, like you say, an asteroid hits it, it's not going to add enough mass for it to matter, for it to affect anything. Our initial angular velocity is 7.29 times 10 to the minus 5th radians per second. The amount of time that the torque was applied was 0.15 seconds, and the final angular velocity is 7.27 times 10 to the minus 5th radians per second. Torque is being applied to cause an angular impulse in this case. Now, earlier in these notes, we saw that torque multiplied by time was equal to angular impulse. We also saw that angular impulse was equal to delta L, which is a change in angular momentum. If A is equal to B and B is equal to C, then A is equal to C. So therefore, torque times time is equal to delta L. We can make a couple substitutions here. First off, delta L is LF minus LI. So therefore, we have torque times time equal to LF minus LI. L is equal to I omega. So torque times time is LF becomes I omega F. Li becomes I omega I, giving us torque times time equal to I omega F minus I omega I. Can factor out I and then divide by T so that we can solve for torque. Factoring out I gave us I times omega F, open parentheses, omega F minus omega I, close parentheses. Dividing by time cancels out time from the left side and moves it over to the right. Our final equation is that torque is equal to I, open parentheses, omega F minus omega I, close parentheses, divided by T. Substituting in our values here, we have 8.04 times 10 to the 37th kilograms times meters squared, open parentheses, 7.27 times 10 to the minus 5th radians per second, minus 7.29 times 10 to the minus 5th radians per second. All of that is divided by 0.15 seconds. Plugging that into our calculator, you should get negative 1.072 times 10 to the 32nd. We only have two significant figures in the 0.15, so therefore this rounds to negative 1.1 times 10 to the 32nd. This is solving for torque, and torque is measured in newtons times meters.